Welcome back. This is Developer's Guide for Windows 10 Insider Preview. Now we're going to talk about XAML performance and things that you can do, Andy, to make your XAML perform even better than it already does. We know how excellent you make your XAML already. Yours probably can't perform much better, but mine has a long way to go.
But XAML, well, yeah, my XAML performance needs help like anybody's. So XAML's a really powerful tool for creating great UI, but it can get verbose. There can be a lot of stuff in it. There can be some stuff that you kind of show when you first load the page, and maybe don't need it until later, or you may never need. And there's some great features in the new release that are going to help you create really performant XAML pages.
So this is where we're going to head down. We're going to start with talking about just conceptually what is performance and kind of what you want to think about and things that may impact that. And then we'll talk about progressive rendering and some deferred loading, all new features in Windows XAML that we have now in Windows 10 that will make it a lot easier for you to really finesse your XAML and make it really excellent. So what is performance? I think that's a worthwhile question and the sort of thing that kind of plays into it. So to start with is startup performance, right?
Yep.
So startup performance is basically how quickly your application appears or how quickly it takes to navigate and show the next bit of content. And so that can really be impacted by several different things, including the XAML rendering engine's ability to parse all the XAML that you had. So you were talking about how much XAML you might include. You could have many nested grids, many nested containers, and lots of different styles and borders and overlays and all of those different pieces. Well, that sort of thing has to be rendered. Well, first of all, it has to be parsed, then it has to be rendered. So we have this startup consideration. And so that's really important. But then there's also the idea around performance of like real-time performance and the interaction of the user and how much time it takes for them to scroll or how your animations perform and pieces like that as well. So there's more to performance than just simply loading data. That's a C# operation. It really doesn't have anything to do with XAML.
Yeah, and actually, there's a topic related to this. We're not even calling out in the deck because it's kind of just part of the framework, and that's the XAML binary format. So one thing to say before we go on to the more fine-tuned, fine-grained techniques is that any XAML you declare in your apps actually gets compiled to a binary format, and so all that is about is making this startup performance, this loading, this parsing much more efficient. So we're kind of at version 2 of the XAML compiler, if you like, and that gives us a big boost to start off with. But that's kind of just there. Every time you build a package, your XAML will get kind of tokenized down to this binary, this token format.
Yeah. So what is it that you're actually compiling down? You're compiling the actual declared XAML, and so this allows us to kind of approach a concept that's certainly not new inside XAML, but one that developers don't always wrap their head around. And so that's the difference between the visual tree and the logical tree. And so when you're coding in XAML, declaring what your UI is going to look like, you are actually building out the logical tree. So I have a grid, and inside that's a stack panel, and I've got a button inside of that. I've got 3 items then inside my logical tree. And then I also have a visual tree. Now the visual tree is realized by the rendering engine at runtime. What happens is, let's start with just a button. A button in the logical tree is just a button, and it's very easy for us to interact with it, and we think about it as a single unit. But inside the visual tree, a button is actually several pieces deep. It includes the border around it. It includes the background color. It includes, and just keep on going from there all the way up to maybe even the text in the middle, right? You have all of these pieces that make it up. Well, where do those exist? Those exist kind of virtually in memory in the visual tree. And so sometimes when you interact with your tree, you have to go to, remember the visual tree helper? I'm sure you've used that before, Andy, where you have to kind of spelunk into your controls and kind of tweak them.
Yep.
Well, the reason that's there is because even though you have a button, it seems like there's just one control and you're nice and lightweight.
Yeah.
You're actually interacting with several different controls that make that the way it is.
And in fact, if you want to have a look at this, anybody, we don't really go into customizing controls, big deal on this course, but if you think about a button, you could just drag a button onto your canvas, right-click on it, and then drill down into the edit template, and you get a little sub menu up there, and you can say edit a copy.
Yeah.
What it actually does for you is exposes what a button is, right? Drills down all the different layers and the contained controls. You'd be astonished, actually, a simple button. You think, well, how complicated can that be? But think about what a button is. It's something that when you press it or tap it or click it, you get some visual feedback. It kind of seems to indent into the page, and it will almost certainly change color and all this sort of thing.
Yeah.
You know, where does that come from? Well, it's all XAML. It's all XAML, and a button itself explodes out into this big
sort
hierarchy.
of hidden into a default template that it has.
Yeah, and multiply that 1,000 times by all the controls you've got on your on a XAML page, and you see there's a lot of complexity in that visual tree. So
that's right.
Yeah,
there's a lot of complexity in a single button. Now you have an application with 10 buttons. You have tenfold that complexity, and so every control has some sort of set of templates that make it up. There are several primitives, of course, where I use a grid. A grid isn't made up of several grids or anything like that. I actually implement it. Being able to extract, by the way, just a quick shout out, being able to extract the template like that is actually convenient. The tool that's easiest to do that in, of course, is Blend. And just last fall or in the autumn, we recorded an all-day Blend Microsoft Virtual Academy course as well. So if that's interesting to you, you can go and look that up, and that's pretty terrific. All right, so now around performance again in the universal side. So not just XAML, but just where we are.
So yeah, so what kind of benefits are we seeing just by the move to the new platform, Jerry?
Significant might be the best way to say it, right? So this chart is actually convenient just to kind of give you a feel for just moving from Windows 8 to Windows 10, how much benefit are we really seeing? And we're immediately seeing some significant benefits. That's because obviously the platform is only getting better with every rev, right? So one of the ways I can improve performance of my application is just moving it into 10 so it's a UWP app instead. You can see the benefits in memory and in startup, and there's several other places as well. These are some significant ones that are kind of fun to look at. There are several performance-oriented XAML courses, not courses, but sessions at Build. And some of these things were covered, as well as some of the field engineers who have some real practical tips that go into very, very deep detail on some of these things. Really, really neat. So just moving over to the universal platform gives us a benefit. Another neat thing inside Windows 10, this is just something that comes for free, is the fact that text renders so much more efficiently than it ever has before, right? So now it renders in half the time, right? 50% more efficient. That is half. Yeah, that's half.
Yeah. So yeah, all this stuff, like that XAML binary format compiler that we're talking about, the platform's giving you a lot of help just to straight to get started with.
Yeah.
But there's a lot of stuff that you as a developer can do as well to influence the performance of your pages, yeah?
That's right. There's 2 or 3 things that we'll cover now that are real techniques that you can use almost immediately. Some of them are super simple, and some of them, to be honest, are sophisticated. You're going to need to think these through in order to get it right. So let's start first about progressive rendering. And I don't know if this is the simple or the sophisticated one. It's not all that complicated, but we're really talking about progressive rendering inside a list. And so back in Windows 8, we had the same ability. It just wasn't as exposed in such a clean way. And so this is the Windows 8 implementation that still is 100% valid today. And so this is the incremental update behavior that's shipped in Blend. And I could go into a data template that was in a repeater, like grid view or list view that supported virtualization. And it would automatically hook up for me to the container content changing, or sometimes we just say the CCC event. And so this is a CCC event repeats inside a container every time, over and over again until it's finally rendered. And so usually when we don't do anything, we let it automatically occur. It just occurs once, and everything inside that template is just rendered for us. But it has this neat ability for us to define the phase, so we can number things inside our template. So let's say this is a CRM system, and I'm showing a series of users. And so my template has the user's picture, as well as their name, as well as their email, as well as a couple other things as well. Each of those components has to render. Well, that's not a big deal for the rendering engine. It can easily do that until there are 10 or 20,000 items, and the user is panning through that list as fast as they possibly can. The rendering engine is quick, but sometimes you end up with a blank screen because it simply can't render anything.
It's the classical thing where you're scrolling fast through a list, and it's trying to keep up. It's getting blurry, and then all of a sudden you're scrolling to black.
Yeah, that's
you're seeing
right.
nothing at all. That's a really bad user experience.
So now, because I have the picture and I have the name and I have the email, those 3 items, let's say, I can indicate on those which phase they're going to render in. And it's basically saying which one renders first and then which one renders next. And so I would say something lightweight, maybe the outline border, maybe just the name and not the picture, because I know that takes a little work, is at a low phase. So everything defaults to 0 if you don't give it a phase, but I could start pushing them out and say the image is going to be phase 2. And so it goes through a cycle before it starts doing the image. The nice effect for the user then is they see the name as they go faster and faster panning. It doesn't go to blank, it goes to just the name, and then if they stop for just a second, there's the image, there's the email, there's all these things as well as the phases quickly render.
So I've got this right. So it will do phase 0 as its like base minimum,
right?
And then it'll only do phase 1 if it can before it scrolls past, and so it's kind of filtering what the visible view is, and it's kind of rendering what it can according to how fast the graphic rendering hardware is and how fast you're scrolling the list. So yeah,
that's right.
Yeah.
And so this is the way we do it with behaviors. And so I can drag this over in Blend, and each item gets a behavior on top of it, and it all wires up properly. And really, this is probably the most efficient way we could have done it in Windows 8. Not even doing it manually. This would probably be the most efficient way. But in Windows 10, we have another way to do the same thing. So that's important to take away. This is another way to do the same thing. Not quite as verbose, and certainly it's a lot easier as well. And so the way we do that is, all right, obviously, phases mean we don't render them all at one time. And the way we do this is with XPhase. So you can see XPhase right here. This is all the syntax of that behavior, all rolled up into a single platform piece now. So now XPhase is saying this item is going to be rendered in what order, basically, where everything starts with 0. And so you can see above it where the display name doesn't have XPhase, that will render first. And then the one that we've highlighted here that does have XPhase, that will render second, and then keep going from there. It's important to say this only works in lists, because lists are what have that CCC event. A little bit of guidance that are probably worth knowing is these phases don't need to be in order, right? They don't need to be contiguous, right, back to back. I could have, if I don't know how things are going to finally lay out, I could go into, in this one, it's the pretty date. I could say it's going to be XPhase 40. It doesn't break anything. It doesn't go 40. It doesn't have to run 39 times in order to run it. It just puts everything out and, like that. But that's pretty crazy. If I did actually have 40 phases that I was moving everything through, that might be a sign that my template is too complicated to really render in an efficient way. So anyway, so don't have too many. Make them manageable is the idea there. And but when you do, you can start phasing them in. If you don't have a lot of data, this may not be a performance tweak you need to do. If you do it anyway, there's no cost. There's no reason not to do it.
It's worth just mentioning on this as well that this just having items progressively realized, progressively shown in a list like that is the simplest thing. There are more sophisticated techniques. You can call out to code and kind of at a certain phase show a simple text item, and then when you get to the full rendering of a list item, you can hide that and show something else. But that's kind of sophisticated techniques. There was a really good session on this at Build 2014, actually.
A year ago.
Indeed. So these kinds of we've been working on these techniques for a while.
That's right. I think I'm glad you brought it up, because it's not a brand new thing.
No.
XPhase is brand new, but XPhase is just introducing a simpler technique to do it. That's all, so that it can be more mainstream.
Okay.
All right.
So that's lists.
That's
what have we got for the rest of the thing?
There's obviously more we need to do, and we'll talk now about deferred loading. So deferred loading is, this is absolutely new. And I think developers have tried to defer load on their own. And so what is this really talking about? And I think let's back up just a second before we talk about deferred loading. And this goes back to the startup time of XAML and the idea that how deep and how complex my visual tree is impacts how quickly it can render, because it has to render every piece.
But isn't it? It's true to say, though, isn't it, that for any sort of moderately or more complex application, if you look at any XAML page, typically, statistically, you look at it and what the user sees when the page first renders is not at all the full content of the page. You'll tend to have bits of content that will be shown later on in reaction to the user pressing a button or selecting something, or there might be a pop-up menu, all this kind of stuff that needs to be built into the page but isn't shown on the first display, and actually may never be shown depending on how the course of however the user interacts with the page.
So it's easy for me to say you should really simplify your XAML, but the reality is the way you've designed your application requires a couple of things in there, and you don't want to oversimplify it so your application doesn't deliver. So that's where defer comes in. So now we have elements that you don't show maybe at the beginning, you only show as you actually need them. And so developers have used visibility to do this in the past. And visibility kicks in and gives you some benefits for sure, but it's not what XDefer does. And we'll go through what XDefer. So first, this is about reducing the number of elements that you have. So being able to reduce the number of elements that you have in Windows 8 actually meant taking them out and you don't have them. You could manually inject them into the tree, but that's really a complicated scenario, and you lose a lot of the declarative capabilities of XAML when you do it that way. So what we do is we keep them out until they're realized. That's what XDefer does. Basically, you're marking a part of your tree, a container or a series of elements that don't show up until they're realized. And realized then is a manual, sometimes automatic process, but basically it's not at the beginning.
And in summary, it's kind of they get realized when you need them, but not before.
You can manually realize them in a couple of ways. So the first would be using find name. And so we've had find name before. This just finds an element by its name. This is the method that goes and checks and verifies that something is realized. As soon as you use find name to get an element on inside your tree, it's immediately realized, and as soon as it returns, you can trust that it's there. Another way you can do that is get templated child inside control templates, or a storyboard or visual state. So referencing an element, let's just say there's a rectangle you don't want to show at the beginning. And so that rectangle you mark to be deferred so it doesn't show up. You put it in a storyboard, a visual state. So whenever a user does something, you want to show that rectangle. Well, because it's in a visual state, as soon as that visual state is invoked, it will automatically realize that for you. And everything about that rectangle then kicks in as if it was loaded for the very first time. One-time bindings that might be part of that all fire immediately. All the events that might need to fire up, touch events and things like that, all wire up then, right? So it really is as if it is just realized for the first time ever. So it's not like it's partially realized and it's there. And what takes up that space, we know how XAML works. There is an actual place that needs to be held for an item like that to realize it would cause your application to kind of jitter a little bit. And so there's a small cost to deferral, a very small cost to deferral that creates a placeholder in its place, a very small, lightweight placeholder that puts another element there as well. So imagine something larger, right? This is an editor. I'm looking at a list of users. Every time I tap on a user, I want a full fidelity editor so I can edit that user. But that's an rich and expensive control to show. So I want to make sure it doesn't show up and doesn't have any cost to my application until the user actually clicks a user, which they may never even do. So I can defer it. And as soon as I do, all the bindings wire up and all of the cost of that to be rendered is spent then, right? And so you can push that off and my startup is faster. So that's the benefit of deferral. Let's take a look at kind of how it goes. So a nice little Zen moment here is the fastest code, Andy.
The fastest code is the code that ain't there.
Yes.
If you don't want it to do anything, don't do it.
That's right. Why would you have an editor and all these other things load up, right, when you don't need to? And I'll demonstrate here in just a second how they load, even with visibility, it just doesn't make a difference. Here's the syntax for load. It's this simple, right? You just find the element on the screen that you want, and you just say X defer load strategy equals lazy. And what it equals for lazy, that means lazy loading, obviously comes at the after the initialization. But that's the only option now, which means there may be another strategy later.
Yeah, it kind of suggests there's going to be kind of, well...
I don't know what it's going to be, but I mean, sort of, I guess hardworking.
How about get up late? I don't know.
Yeah, very lazy.
Yeah, I'm really not interested.
Yeah, I don't know what it's going to be, but lazy is what we have today. It's this, and once it's there, it doesn't instantiate, it doesn't render, it doesn't have any cost, but it's also not there. So you can't go interact with it until you've realized it. All right, I think this will make more sense if we see it in a demo. So let me just kind of draw this out so we get a feel here. I'm going to open up Visual Studio, and we'll do everything here from blank. So this is a blank template 10 application. And I'll just build out some simple things. And you know what it will do? Let me go in. I'll create a quick class here that will be a grid. I'll just call it my special grid here. I'll inherit from grid, and the reason I'll do this is just so we can keep track of when it's instantiated. So all I need to do is set up some defaults, so I'll drag this in. I don't have to do this over and over that way. I'll set its color to be, I'll set a solid color brush to be steel blue here, and I'll space them out with a little bit of margin. Okay, this is all I need. So now, 10 we'll say. But what I want is to use the debugger just to write out a quick counter of what's created. So in this case, I'm going to spit out a counter here. It's just going to be a field, and I'll make it static so that across all of them it keeps counting up. So basically, every time I create one of these, I'm going to get a created count, and it'll just keep adding to show me how many are actually instantiated. All right, let me add this now to my application. So I've got my special here. It's got a whole bunch of things. I'll put it inside the core stack panel. And let me kind of clean this up. There's a little bit of stuff. There we go. And so I'll add 1, 2, 3, 4, 5 of these. And let's just switch over and run it. And I'll show you. We should have 5 blue rectangles. Now, more importantly, we'll have 5 blue rectangles, but we'll also hopefully have 5 messages in our output window. Well,
whoa.
There you go. Yay. So created with 0 based. 0, 1, 2, 3, and 4. So that's the 5 that were just created because that's what we did. Right? Yep. All right, so that's just kind of showing it off. Let's start with what developers think works. So a lot of developers think that setting them as collapsed saves them the cost of instantiating the control.
This is a commonly misunderstood thing.
Yeah, so I'll run it again. And so created 1, 2, 3, 4, and 5, or 0, 1, 2, 3,
they're still there in the tree. They're still being created. Yeah.
Yeah. So that doesn't stop them from being instantiated. In fact, some developers think that it's not visibility, but it's opacity. So let me add opacity, and we'll set its opacity to 0. Hang on. There you go. And I'll set all of them to 0. And we'll run this just to see what would happen. So, when it's not visible, it doesn't render, right? Well, that is true. It doesn't render, but it does instantiate. So you have this cost of all the elements that are actually present. All right, so let's make a change. Let's use Deferred Load strategy. I'll set it to lazy. We know that's the only option I had. And so I'll say 1 isn't. And so we'll try and run it. Get this error because now I need to realize something. And all of those realizations had to do with its name, so I can't not have a name. So it requires that it has a name in order to use the strategy. I'll go ahead and set a name for all of them, making them unique. All right, now let me run this and look in the output, and I have the 1 at the bottom, but in the other 4, they're not even instantiated, let alone rendered, right? So I save all the costs that might have been there for those 4. So that's a big win. All right, so now let's try and actually realizing these manually. All right, so we'll do it in the loaded event, and we'll make sure everything's there that way. And using just the find name, remember it was special 1. That was the first one. And so that should make it so that I realize just 1. So we should see created 1 and 2, or 0 and 1. And I'll write down loaded here just so we can see when that occurs. All right, so let me debug. Runs like normal, and the result is created 0, then the loaded writes, and then created 1 because I realize it using find name. And so now I'm slowly building it out, and I can kind of rely on it. But what if I tried to call it? Special 1 is there, so it feels like I could interact and set its visibility, let's say, to visible. Right? That should work in my mind. It's going to build just fine, deploy just fine, but as soon as runtime hits and I try and interact with something that isn't realized, I'll get this error that it's a null reference exception. That's because special 1 doesn't exist yet. But if I moved it down like this, ran it again, I'll have no problem executing it because it's realized because of find name. That makes sense?
Yep, completely. Yep.
I mean, it's an easy thing to do, to add this defer strategy just like that. and all of a sudden you have different pieces of your application or your UI that cost nothing to have. I could have a different visual state for narrow and wide and different things like that, a portrait, landscape, whatever it is I have, and I can make sure that those don't increment the cost of my application's startup time.
And I guess if you put this on a container control, like a grid, any children inside it will kind of inherit that.
That's exactly right.
Yeah.
That's exactly right.
So you don't have to put it on every element. You just,
no, it'd be exhausting.
Typically, you'd have a block of content that you're going to show according to, like I said, the user clicks a button or something. Maybe you show
right.
something that doesn't need to be there when the page is first rendered. So this is ideal for making that startup time quick.
And binding and events and all those things aren't there. They just suddenly would be done. As soon as I call find name, the bindings get set up, the events get set up, and so all of the things you would expect at startup to happen. So developers have to pay attention to what they're doing.
That's cool. Yeah.
So there's 3 types of virtualization inside a XAML application. The first one is visual virtualization, and the reality is you get that for free. I set something to collapsed, and it doesn't appear, right? And I don't have a cost of the full cost of rendering, but as we saw, I still have the cost of its instantiation. So it's not zero, but you do get a little bit, just the fact that no pixel is currently visible. So that part is great. But there's 2 types of data virtualization as well. So I see the object, but I don't, and it's showing a list, always with a list. So I'm showing a whole bunch of records, let's say 1 million records, which is ridiculous, but let's say it's 1 million records. I can't afford to render those at startup. So the first option is sort of like Facebook or Twitter or those kind of things that just go on and on and on, and it seems like they're endless web pages, but what's occurring is as I approach the end, there's a trigger that fires that loads a little bit more. And as I approach the end, there's a trigger that fires that loads a little bit more. This sort of incremental loading is built in as fully supported virtualization inside the list objects like list view and grid view inside XAML, so that you can build the same behavior inside your application.
So what we're talking about here, is like a very, I remember writing a blog post for Windows Phone Silverlight where I had a list which was bound to a collection of items which actually had, I think it had 1 billion items in it.
Good gravy, that's a lot.
Well, because it didn't matter. It was a very, very large number.
Did you ever scroll to the end?
No, I never did. But the point is, that these list controls, they know that there's no way you can actually render and store in memory the list items for 1 billion items in a list. So it's all about making sure that the ones the user can see and a few each side are there and concrete and are ready for showing.
1 billion's a good number actually, because if you did need to see the last record, right, it would take a long time to scroll there, and so that's where random access virtualization, the other kind of data virtualization, kicks in. This allows the user to see a somewhat realistic scroll bar, but they don't have to slowly progress. Instead, they can grab the scroll bar, move all the way to the end, in the middle, wherever it is they want to go, and then that individual page or that view of data is what's loaded for them. So I can jump from 0 to 6 million, and I don't have to load 5 million records in between. I just jump to the ones I have. So the 2 types of data virtualization, that's random access that I just described, and then this incremental that seems to go on forever. And so both of those are really great and can really improve your startup time. Certainly you wouldn't want to load 1 billion items all at one time.
Cool.
That's some of the core pieces of performance in a XAML application, right? So first, just what is performance? Sometimes it's just startup time. Sometimes it's the other things that you're doing as well, being able to navigate through lists and other things like that. And we got to see kind of the tools that developers get for free and some of the new ones that we're seeing in Windows 10, like progressive loading using XPhase, and then deferred loading using Deferred Loading strategy.
Yeah,
that's right.
And it's worth mentioning there's some great tools built into Visual Studio for monitoring the memory and the responsiveness of your application. We're not covering them now, but those are in Visual Studio, and you can use those to watch how your app is flying now with these great techniques.
Just moving to the new platform, obviously that gives you some benefits as well. That's obviously your first step. But the next is, don't forget, you have an awesome computer. Your users probably don't, and to test it on real hardware so you can see what their experience is as well. Okay, Andy, that's performance. Definitely a great way to end the day.
Yep, that's really nicely wraps things up for that first day.
It does. For this first day.
This first day.
And if you are watching, don't forget there's a poll for you to be able to take and participate in that. And we will wrap it up here and come back tomorrow morning, fresh, early,
Yep.
ready to go, tan, rested.
Yeah, we're going to be looking at adaptive UI, adaptive code, all that stuff about making your app work across different screens and different devices.
That's right.
All right.
We'll see you then.
See you then.